hi everyone, my name's Jess. I'm from the Faculty of Engineering. I'm studying a Bachelor of Engineering and my specialisation is electrical.
G'day, my name's Isaac. I'm also studying engineering, specialising in aerospace. So today we're going to take you on a bit of a tour of some of our facilities, our fantastic venues that you can access as our Bachelor and Masters of Engineering students. To kick us off, we're going to cross to our Dean of Engineering to receive her welcome.
Hello everybody, my name is Elizabeth Croft and I am the Dean of Engineering here at Monash University. I am speaking to you outside the Woodside building for technology and design. In this fantastic teaching and learning building, our students are learning about clean water, new design techniques, about sustainable development and energy, how we can make this world a better place for everyone. This is the place where it happens here at Monash University. We're looking forward for you to come and study engineering here with us.
Thanks so much, Professor Croft. The Woodside building is actually really amazing. I've had a majority of my classes there so far this year and it's been really good. Also, fun fact, it's a living building and it's actually the first in Australia to receive Passive House certification, which is awesome. And one of the coolest parts about it is it's home to our design and build studios. That's a place that students can come to prototype things that they've designed themselves. So it has a whole host of 3D printers and tools that they can use. Isaac, can you tell me what Passive House certification means?
Look, I can tell you a little bit about it. I know that it is involved around the material choice used and how we capture the air in the space and how we treat heat regeneration from the mechanical ventilation system, but that's about as much as I know. What I do know is that it's a step on Monash's journey to a net zero emissions in 2030. So if you'd like to find out a little bit more about Passive House certification, you can Google Passive House Australia. It's really easy to find some info. Did you know that Woodside also produces a lot of data for students to analyse, and they can do that in a number of software packages. What software have you been using through your degree, Jess?
Yeah, so I'm studying electrical engineering, as I said before. As you can imagine, there's a lot of circuit analysis and stuff like that involved. We use tools such as LT-Spice to work with that. But a fair amount of what I do is actually programming based. So I use a whole host of programming languages like Python, C, C++, and mathematical analysis tools like MATLAB, which I know a lot of engineering students do heaps of. Yeah. But I'm also part of a student team called Monash Motorsport, which has given me an opportunity to work with other softwares as well. So I've done a lot of CAD design using NX, and then I've also helped to develop PCBs, printed circuit boards, by myself using Altium, which is awesome.
Yeah, that's great. So now we're going to take you to Civil Engineering's Visualisation Lab, where some engaging technologies are being used by our students and academics, simulating construction environments to enhance safety and efficiency. The lab is also used to address matters in road safety and to aid in autonomous vehicle developments. Over to Dr. Yihai Fang and Professor Lihai Vu and the students who run the spaces.
Hi, my name is Yihai Fang from Civil Engineering Department at Monash. Now I would like to show you around our visualization lab, and I can't wait to show you the exciting work and the cool gadgets we have here. Now first off, we have Jensen here testing a simulation program. So we're leveraging virtual reality and reality capture technologies to create a really realistic scene for the crane operator to operate in a virtual environment. So in this way, the operator can virtually rehearse a very risky job in a risk-free environment. To make the scene even more realistic, we're leveraging the laser scanning technology using this device. So the device will capture the 3D surrounding environment within a very short period of time and with very high precision. So you can see the environment is enriched by the point cloud data, so the scene will be more realistic. And Jensen here is operating the virtual crane, and we're setting all different mechanisms to identify the safety risks during this virtual lift practice, so that we can address these safety problems even before the actual lift takes place. And Jensen is using a very powerful PC virtual reality system. We also have the mobile virtual reality systems and also the HoloLens for augmented reality. So we're testing all these different forms of virtual reality and augmented reality trying to understand how they can be used the best for the training purpose. All right, next up, we have Mustafa and Leo here trying to examine this massive 3D point cloud data, also collected by that laser scanner you saw just earlier. So here we're looking at a offshore platform. It's a massive structure, and by leveraging this spatial data, we can, well, Mustafa, if you can show us the corrosion part. So we can closely examine the corrosion and paint condition of the bottom part of the structure. And if you move to the drill tower, we can also using this data to assess the structural integrity of the most critical part of the structure on this platform. And we can also understand the maintenance activities. So there are a lot of different materials lifted to the platform for daily maintenance. And here we can view and optimize their layout on the very precious space on the platform. And we can also pull up the 360 image captured during the scan, so we can view the scenario even more closer. And you can see we're taking advantage of this very big and high resolution screens so that we can leverage its full capacity to view a massive data set like this. All right, thanks, Mustafa. And next up, in this small room, we're trying to make this a dedicated space for transport research. So here we have John to demonstrate to us a VR program together with this physical simulator to study the driver's behavior when they merge to a highway, on a highway merging lane. This is very important because we want to understand how the driver perceives the risks and how they react to the risks. In this way, we can design the road network, the lanes better. At the same time, we can also design our autonomous vehicles to adapt to a mixed model traffic scenario. By mixed model, I mean both autonomous vehicles and vehicles driven by human drivers. So you can see Jim was wearing the VR headset to have a very immersive experience. And at the same time, we can view the entire process on those screens from a third-person view, so we can understand the behaviors better. All right, that's pretty much about our visualization lab here at Civil Engineering. And next up, I'll hand it over to Haiwu for the autonomous vehicle. Thank you.
Hi, everyone. Welcome to the Autonomous Vehicle Lab. My name is Haiwu from Civil Engineering Department and at the University of Monash. So today I will show you about our work using and developing autonomous vehicle. And what you see here is a level 3 autonomous vehicle, a 3Z, which can drive by itself. But before we can doing that, let me show you some of the things that we are work here with the team. So in the back, you can see one of my students working on the simulation and testing out the algorithm and the technology that we develop here for the autonomous vehicle and driving it in the simulation. So the reason that we need to testing it and driving it in the simulation is to make sure that the algorithm and the technology that we develop here in this autonomous vehicle are safe to be operated in the urban environment. So what Farouk, my student, doing here is driving it and testing out different algorithms in the simulation environment. And once everything is ready, we can then trial that in the real environment. So we have a very big team here with lots of students working on different areas such as algorithm development, path planning, and also human behavior, both in terms of how you sitting in the autonomous vehicle, what do you perceive, and also how the autonomous vehicle interact with other people outside in the urban environment. So there's a lots of cool and exciting stuff happening here, and I hope that you will be having a chance to come and visit us and potentially also join our team to develop new technology for the future. Thank you again for visiting us today. Have a good day.
Thanks, Professor Hai and Dr. Yi Hai, and all the students involved in that video. On the topic of autonomous vehicles, as I mentioned before, I'm part of a team, Monash Motorsport, and we're currently developing our second iteration of our driverless vehicle. So for about 20 years, we were focused on making combustion vehicles. You'd know them as like petrol kind of cars that you see on the street. But in recent years, we've moved to electric and now even autonomous. And the plan is to take it overseas next year and compete in Europe in the Formula Student University competition, which is really exciting for us.
Yeah, awesome. This provides a great segue to our next space, and it's a space where Jess and I probably spend most of our time at Monash, particularly through this winter break. The Monash Makerspace, home to Monash Motorsport, to Monash Unmanned Aerial Systems, Precious Plastics Monash, and my very own Monash High-Powered Rocketry. The Makerspace is a state-of-the-art prototyping facility, and it has fabrication, machining and light technical areas where students can dream, design and make, engaging with authentic projects and developing their skills as engineers. And it's great to see, I'm the team lead of High-Powered Rocketry, and at the moment we've just done a bit of recruiting, and it's really great to see where students come in their first and second years to the team, all through the process up to someone who's spent 3 years on the team now, and they're really right in the depths of design and really strong engineers. So Dr. Scott Wordley, who manages the space, is going to take us on a tour of the Makerspace. So over to you, Dr. Wordley.
Thanks, team. Hi, everybody. I'm Scott Wordley from the Monash Makerspace. I'm the Director of Student Teams and Clubs here in the Faculty of Engineering, and this is one of the amazing spaces that we have for the activities that all of those teams and clubs do. So let's go for a little bit of a tour. Before we kind of take you into all the technical stuff, we just wanted to point out the amazing little kitchenette and chill out area that we have over here, where everyone gets to eat their lunch and catch up and talk to their mates. Behind us here we have a space that we're commissioning that's going to have some of our new CNC machines in there, so that we're going to have a computer numerically controlled mill and lathe going into that space so we can make really high precision parts. On my left and your right is our light technical area where the teams hang out and catch up on their teamwork and work on their laptops. And then we're going to take you for a quick tour through our composites area. This is where the teams will work to manufacture carbon fibre, fiberglass and Kevlar parts. We can see we've got our material racks over here on the left. This is a foam mould that the motorsport team have manufactured to make their wing. And over here you can see where that skin has come out of the mould there, made in carbon fibre, and it's getting joined to the other bits and pieces of that wing. This is a wire cutting machine which we use to cut out profiles out of pieces of foam. And here we have the start of our 3D printer farm. So we'll very shortly have a wide range of different 3D printer technologies along the wall here for all of our teams to use for their projects. We're going to pop out now and have a look at 4 of the teams that actually reside in this space. The first team we're going to visit is Monash High-Powered Rocketry. So they've built these amazing rockets that you can see here. This one went to 30,000 feet in the most recent Australian competition and came second place in that event. If we take a little bit of a tour of their workspace, let's see what they've got on show here. In this box, we have a couple of different 3D printed fuel grains that will go into the hybrid engines that this team is currently developing. And what else have we got to show you in here? Okay, over here we have part of the new fuselage that the team have been building, and they've created it with these 3D printed molds that bolt together to be able to manufacture that component. So that's our HPR team, Monash High-Powered Rocketry, who live next door to our Monash Unmanned Aerial Systems team. This is the airframe from their competition-winning entry a couple of years ago in the Australian Outback Challenge. This aircraft was able to take off and land vertically fly about 30 kilometres to a search zone and find a stranded bushwalker, and then land and take a blood sample and then autonomously return to base. So really impressive hybrid fixed wing and drone aircraft that they created. Our next team is Monash Precious Plastics. So this team works on a global plastics recycling initiative where they get waste plastics and they shred them all up, and they design and build machines to be able to manufacture new products for them. So we can see some of the products that they've manufactured here. Over here are some of the presses that they used to press the materials into sheets, and then over there in the laser cutter they will actually program designs into the computer and then have the computer cut out those designs to make their products. These are some of the amazing coloured sheets that they've manufactured. That's Precious Plastics Monash. Our fourth and final team that reside inside the Monash Makerspace is Monash Motorsport. They manufacture combustion, so petrol-powered cars, electric cars, and also driverless cars for a competition called Formula Student and Formula SE. They compete in Australia and also around the world in Germany, Austria, and the UK. This is their 2019 car. It's an electric car, and this one won the Australian competition in that year. It's really cool. It's got a single motor at the rear and a big battery pack, and it's got a carbon fibre chassis. Over on my left here, we can see the new 2021 car that is gradually taking shape. So this is the carbon fibre monocoque that they've manufactured, and they'll start bolting all the suspension and powertrain components into this car. This one is going to be a four-wheel drive car, so it's going to have a motor at each wheel to enable it to have even higher performance than the previous cars. This one here is our first driverless electric car. So with the help of sensors and computers and LiDARs, this car is able to detect where it is on the track and figure out how to drive itself around. So really interesting new technology in autonomous vehicles. On my right-hand side, we can look in and we can see our manufacturing and machining area. So in here we have lathes and mills and drill presses. So heavy engineering machines, industry level stuff, and we send our students to TAFE to be able to learn all the skills that they need to be able to operate these machines safely. We're going to go to my left now and just show you quickly our electrical area. So over on this side we have a wide range of high-end electrical diagnostics and scopes to enable us to design printed circuit boards and to solder all the components to them and to be able to work on various aspects of the electrical engineering things that the teams do. And just finally we'll take you and show you the fabrication area. So this is a space that we use to manufacture metal objects. So we might cut and grind things over here and throw a lot of sparks around. We've got our welding bays where we can weld and join bits of metal together, and our large jigging table where we can make large structures very accurately. So that's our fabrication bay. And with that, you've pretty much seen a really quick tour of the Monash Makerspace. Our students are currently doing exams, but we're looking forward to welcoming them back soon. And then this place will be buzzing again. So thanks for checking it out, and we can't wait to see you at Monash soon. Thank you.
What a cool space. And I mentioned before that that's where Jess and I spend a lot of our time. And my time in that space is mostly working in the high-powered rocket team, where we're working on not only building and launching rockets to 10 and 30,000 feet in national and international competitions. We're also working on developing our own propulsion system. So it's great that our students can engage with that cutting edge space technology, and that really drives me personally and the team. So it's also good that any student across Monash Uni has the opportunity to access the Makerspace. What have you been up to recently in the Makerspace, Jess?
Yeah, so my team Monash Motorsport has been fully in the swing of manufacturing things right now, which means it's been like a heavy last few weeks of putting everything together. As you can imagine, heaps of fabrication, heaps of machining going into it. But as I mentioned before, I'm an electrical engineering student and I'm part of the electrical systems department on the team. So I've been spending most of my time in the high voltage area in Makerspace putting together a battery pack, which is loads of fun and really exciting. But yeah, now, before we finish up, we'd like to take you on a tour of one more space. We'll be taking you over to the Process Control Lab. It's part of the Chemical Engineering Department, and it's a unique lab built to enable students who study biological and chemical engineering to remotely gain hands-on experience with real-life lab equipment. Find out how by Mark Banasak-Hull and Dr. Joanne Tanner.
Welcome to Chemical Engineering at Monash. Today we'll show you a little bit about some innovations we've done in the chemical engineering lab teaching over the last year. Joanne Tanner's here with me, and she'll be explaining some of the great work we've done to make our labs accessible to anyone, anywhere, anytime.
So last year, when Melbourne was in the midst of the pandemic lockdown, we decided, look, that's not going to be a great experience for our students. They're going to have a lot of online learning, lots of videos, nothing really very interesting or hands-on or interactive. So I went to Mark and I asked him if I could build a new lab.
And I said, of course. And so what we did is we made it so that Joanne could make a new way for students to remotely run real equipment, but run it remotely like a real chemical engineer would be doing it from the process control room.
That's right. So we started with process control, one of our third-year units. And in process control, normally what an engineer is doing is they're designing and they're interacting with software to run equipment. So that's exactly what we did in the lab. We got some equipment, we put it in the lab, we had a demonstrator helping to run it, and the students did everything else themselves online.
And we talked to the students about how it went, and the feedback we got was pretty good. And so Joanne and I talked some more, and I said, wouldn't it be wonderful if we could expand this to more of the units that our students are taking? And so we went after a really challenging one, thermodynamics.
We did. In fact, 2 thermodynamics units, both our second and third year, now also run fully automated, remotely accessible labs that can be run by the students from anywhere in the world.
This one really excited me because I struggled when I took thermodynamics. I found it really hard. I found it could be very abstract. And so it was really important, I thought, to make sure that our students could still do the hands-on laboratory work with our real equipment to best learn the content of these classes.
So that took care of some of our core units and the really important, really hardcore chemical engineering stuff. And then we thought, how about we'll expand it again, Mark?
Yeah, so Joanne was amazing, and she said, you know, we could bring this into one of the biggest initiatives going on in the department, all the new work we're doing in biological engineering. And so we're really excited. We brought this into our sustainable processing unit, and Joanne worked with a whole team of people to bring this to fruition. Let's go look over here and take a look, Joanne.
So over here you can see we've put up a biological engineering pilot lab. The process here is fermentation, a classic, very, very applicable, both chemical and biological engineering process.
So Joanne, when you came to me on this one, it was just amazing because in this case, we had a student team, the Monash Brew Lab, that was working on fermentation, brewing beer.
Indeed.
We had the Zothologist, a student spin-out company that had come from that student team and was now commercially brewing beer here in Melbourne. So they could come and be part of the teaching experience for our students.
Having these teams involved was amazing, Mark. What they did was they helped us not only with the process, but with helping to make it a really authentic, inclusive experience.
Even better, this bioprocessing unit is directly connected in the way we're teaching it to BioPria. BioPria is our oldest engineering institute with incredible industry contacts.
I actually work for BioPria myself, so I can attest to everything Mark's saying. It's an amazing institute, and they gave us such great support for this authentic user experience for our students who are getting real hands-on experience from anywhere in the world, exactly as they will do when they go out and pursue their engineering careers.
So this just gives you a little flavor of the sorts of things we're doing to make sure that no matter where in the world you are, you can run the laboratories in an authentic chemical engineering fashion. You get to interact with real equipment and do real laboratory work. And there's one other key piece of this. Joanne, talk to them a little bit about how important digital twins are and how that relates to all of this that we just showed them.
Absolutely, Mark. So here you can see physical equipment with control systems that you get on and you can operate. But what if you didn't have physical equipment? Or what if you were trying to design a new process? Wouldn't it be great if you had a virtual version of that process? So that's something else that we're really keen on here at Monash, is virtualizing some of our labs. So not only do we have them remotely accessible, they're accessible all the time to everybody.
Whenever I talk to the industry leaders running chemical processes in industry now, they tell me how important that digital twinning is for the work they're doing. So Joanne, just thanks again for your great leadership that you've shown, bringing all of this ability to remotely run the experiments to the Monash chemical engineering students.
Absolute pleasure, Mark. Thanks to the students for participating.
Thank you very much, Professor Banaszak-Hall and Dr. Tanner. It's really great that our students from around the world can log on and control those processes from their homes. It's very reminiscent of our last year with high-powered rocketry, where our teammates were able to overcome the restrictions of lockdowns and collaborate in real time to create some outstanding results, including our recent success at the Spaceport America Cup. It actually replicates the real world of process engineering too, which is great for us as students.
Well, that pretty much wraps up our tour for today. We really hope you've had a great time and that you've gotten a sense of what we do in engineering and how you can become a professional world-class engineer at Monash University.
And we hope to see you at Monash Engineering soon. So take care and stay safe, and thanks for listening. Thanks for watching.
Thank you. Bye.